All right. Assalamu alaikum to everybody. I hope everybody is fine. First of all, I would like to thank the IEEE KFUPM student branch for inviting me to give this seminar on Introduction to Cloud Computing. It's really a pleasure and honor to be here along with KFUPM students. And if there are any faculty and staff also, I would like to convey my regards to them. And I'll quickly, in 1 minute, I'll just give my introduction. My name is Abul Bashar. I'm a faculty in Prince Muhammad bin Fahd University in the Computer Engineering Department. We belong to the College of Computer Engineering and Science. Uh, I've been a faculty here for almost 10 years now. And before, I used to actually work in KFUPM in the electrical engineering department as a instructor. So I have uh, close association with KFUPM, and I know people around there in the faculty in the electrical engineering department, and it's really something very nice to be again in touch with you. And I hope today we will have a nice evening learning some of the introductory concepts on cloud computing. So I will uh, give chance if needed to you. If you have any questions to ask, you can always send a chat message to me. And anyhow, at the end, we will have a Q&A sessions for any clarifications. So let me get started. And that's the outline of my presentation. Here are the few important concepts which you should be learning uh, after you are done through this uh, seminar. Okay, so we should be knowing what is a driving force behind the cloud computing, and what is the cloud reference architecture in terms of both the infrastructure and the functionality. What are cloud applications and services? What kind of infrastructure in terms of hardware, in terms of virtual infrastructure, in terms of software defined infrastructures, which are very popularly used in the cloud-based environment. Security is a big issue in the cloud. We'll be spending some time on that as well. How do we bring about business continuity when we are depending on the cloud environment? Then at the end, towards the end of my seminar, I would also touch upon a few basic related technologies when we talk about cloud. That is the edge computing, fog computing, IoT, big data. So finally, I will conclude. Before the conclusions, I will just present some of my research work in the area of cloud computing. So just to confirm that you are able to hear me clearly, are there any issues with my voice?
Yeah, go ahead, Doctor. It's all clear. If there is any issue, I will.
Thank you. Thank you so much. Sure. Thank you, Mr. Anas. Thank you. Right. So let's get started with the concept of the digital transformation. Okay. So if you look around, I mean, this has been there for a while. Actually, we can see that the main components of any system, like the customers, the competitors in the business environment, and the things themselves, all are going digital. Uh, Gone are the days when we used to deal with analog systems and analog devices. So we are all going towards the digital transformation. So digital transformation is a process in which you basically work with inputs which are digital, your system is digital, and the output is also digital. This does not only belong to the systems, it belongs to the people who are using it, it belongs to the businesses who are running these digital systems. So, keeping in mind the digital transformation, here I'm just going to quickly give you a few companies who are actually very popular in the digital domain, which are Uber, Facebook, Alibaba, Airbnb. So there's something unique about these companies. These companies are not written here in a random way. These companies, actually, if you look at the Uber company, uh, it has no vehicles, but still it is running its business. It's a transportation business. Look at Facebook. They don't have their own content. They are still running a big social media uh, service without having any content. Alibaba, for example, they don't own any products. They don't have their own warehouses. They are still running a retail business. Look at the Airbnb. They don't have any real estate, but still they are into the hotel and the tourism industry. So what these companies are doing is basically they are leveraging the benefits of this digital transformation. All they have to do is do their business in a digital way. That's all they are doing without having to invest heavily into the infrastructure. Okay, so if you look at these companies, you will really appreciate the kind of benefits which we can achieve with the uh, digital transformation phenomena which is happening. If you look around, you will find that these businesses have something common in them, and that is all their needs are software driven. Okay, so if you look at the infrastructure, if you look at the services, you will find that there is going to be a huge dependency on electronic format of their data, the software which is running behind their businesses. All these give them too many advantages in terms of business opportunities. They can make personalized experiences for people who basically those are the customers. They can innovate very quickly in an agile way. They can operate in real time. They can provision services very quickly so that they don't lose their customers, and they provide definitely transparency and trust to their customers so that they can retain them. And how is this possible? So there were some companies which took the lead and they adopted the digital transformation. These are called as the digital leaders. Then people started to follow up. They started to adopt later on. After the digital leaders, we came to the digital adopters. Then the slower ones were the digital evaluators, where they took a lot of time to evaluate the technology and then they jumped into the digital field. Then we came with another companies which are called digital followers, and finally the digital laggards. These people, they did not even realize that businesses can be done in a digital way. So this is how we can actually evaluate how people have actually used the digital transformation um, to their advantage, and how quickly they were able to adapt to these uh, upcoming technologies. Okay. Um, yeah, definitely there are certain business challenges which need to be addressed. For example, a lot of companies doing same kind of business, so there is a rise in competition. You are in desperate need of having customers to your business. Okay, then how quick you are in marketing your products and services, and how you are good in predicting who is going to be basically the user or the customer for your services and products. So all these business challenges um, could be addressed, as we will see later on, with the help of cloud technologies. Okay, look at this person standing over here in front of his data center, and he's all messed up because he has to deal with these IT challenges which come on a very frequent day-to-day basis, and he has to deal with all such issues, which include data growth, too much of data coming up, how to store, how to manage, how to process, how to secure it. Okay. On top of it, you have the financial pressure to do job in a minimum amount of budget. Then the old hardware technology, they give up, they break, they slow down in their services, they cannot scale to different needs of the business. Security is another issue. So these pressure on the IT manager, um, they need to relieve it somehow. And the solution to that is basically the cloud. Cloud provides all these actually solutions to these challenges which are encountered by the IT managers on a day-to-day basis. So that's what is the digital transformation, which is a key enabler for the cloud computing systems to be in place and to be adopted and to be widely used. However, when you look at the cloud computing technology, you need to make some changes. You need to make some changes in your organization. You have to invest. You have to invest in your people. You have to invest in your process, and you have to invest in the technology which you're going to use. There are details which will come later on, but this is something which has to be kept in mind, that adopting a new technology by no means is a cakewalk. No, you have to spend considerable amount of time, effort, and you have to convince your people that this is something which is something good for us. So what is cloud computing? Let's take a very formal definition, which is provided by NIST, which is an organization in the US, National Institute of Standards and Technology, which actually gives us a definition of the cloud computing. It says it's a model for enabling ubiquitous, convenient, and on-demand network access. Ubiquitous means it is available everywhere, it is convenient, easy to use, and it is on demand. On demand means as soon as you need a service, it is there for you. You don't need to wait for it to be provisioned. And it is configurable. It's a shared pool of configurable resources. These resources could be your servers, your storage, your network applications or services, you name it. And they can be rapidly provisioned, meaning you can get these services as and when you need without much of delay or latency. Okay. And from the IT management point of view, this is possible with the help of very little effort from his side. Okay. Now, if you look at the diagram here, there is a cloud, and you have all these infrastructure inside it in terms of your computing resources, your storage, your network, your applications and services. All these are running within the cloud data center, and the consumers or the users are going to access them through any kind of a network. It could be a local area network, it could be a wide area network, or it could be based on a wireless network, and or it could be your mobile data network. And you could access them from any type of hardware. It could be your desktop, it could be a laptop, it could be a smartphone, or it could be any small computer device for that matter. So that's the main idea behind the cloud. So how the cloud is different from the traditional IT infrastructure, okay, in terms of its management and how it is owned. So we know that the traditional IT resources, which are part of the company itself, they are owned by the company. They are the sole owners of that IT infrastructure. However, in the cloud, it is not the ownership, but it is actually a rented. It is a rented service. Okay, so you don't own it, but you pay the rent as and when and how you are going to use the service. In terms of time, it takes a lot of time for the traditional IT to bring it up. You need to purchase the equipment, you need to set up, you need to configure, you need to plan your applications. you need to provision the services. All these things takes time and effort. But on the other hand, the cloud is on demand. You get it when you need it. Okay. Traditional IT is to be upgraded all the time, you know. So you purchase your hardware, after maybe 1 or 2 years it gets outdated, you need to update it, you need to be continuously monitoring what kind of hardware is part of your system. However, in the cloud, these things are done by the cloud service provider, so you don't need to worry about upgrades, okay, and maintenance also. IT resources in the traditional world, for the peak usage, you purchase a heavy equipment, okay, with lots of capabilities, but you rarely actually use it. Okay, so you are basically not using the resources efficiently. However, in the cloud environment, you use as you go. Okay, you pay as you go. Okay, so when you use it, you pay for that only for that amount. That means your resources are utilized in an efficient manner. Coming to the cost, definitely traditional IT requires a lot of money investment. However, it is very cheaper for you to rent a, cloud service. Let's say you are renting a virtual machine from Amazon or Google. It will cost you like few dollars. You know, so there are certain essential characteristics the cloud provides us, and that's actually the key reason behind the popularity of the cloud computing. Resource pooling. So you have all your resources, be it compute, storage, network, applications or services, all these resources are pulled together. So when the things are pulled together in a one place, it is easy for you to manage them. It is easy for you to rent them. It is easy for uh, to provision them, to stop these services. So that's the concept of the resource pooling. And it is shared. That means no single person uses this is for them. No, it is shared. So as you finish your use, you just return these resources back to the pool and somebody else is going to use it. Rapid elasticity, that's another big advantage. So based on your demand, based on your usage, based on your workload, you can increase and decrease the amount of resources which you need to use. That means as your need grows, you increase the number of resources. As your demand goes down, you basically reduce it. So this is one another big characteristic of the cloud. The services are measured. I just now explained this. It is pay as you go. So you don't pay something extra and which you don't use. Okay, so basically this is utilization of your money in a proper way. On demand self-service, you can provision these services on your own. You don't need to be dependent on anybody to actually help you to make a service for you or provision an application for you. You can do it on your own. You just go to the cloud portal, you look for your services, and you just buy it or you rent it basically. And it is on demand. It takes very less time actually to get these resources. Broad network access, this is a big advantage. You can access the cloud computing services through a broad range of devices. As I gave you the examples, laptops, workstations, smartphones, and so on. So the cloud is very flexible in that sense. So what are the possible applications which you can do or services which you can rent from the cloud? You can rent backup services, you can run computing services, you can use some of the softwares on a trial basis from the cloud, and you can use the latest technologies in terms of operating systems, in terms of libraries, in terms of applications. You can have the latest versions available to you. But such is not the case in the traditional IT. So definitely cloud is a very beneficial system. Okay. Here are some of the benefits which I have been actually talking about. money. Okay, and you are basically giving new services to the customer won't leave you, so they will be with you. um, let's go to some technical stuff now a little bit. Some of the key terminologies which you might have actually heard when you are talking about cloud. So cloud has two types of models. One is a service model and the other is a deployment model. In the service model, you can have infrastructure as a service, platform, software. Some people try to combine all this together and say this is everything as a service. Okay. um, when it comes to the deployment models, this is the way in which your data center is arranged and who has access to it. So it could be a public cloud, it could be a private cloud, it could be a community cloud, and it could be a hybrid cloud. So two different types of models, service and deployment. So let's look at the service models very quickly. So if you have heard about Amazon, Amazon provide the EC2, Elastic Cloud Compute. Okay, EC2. This is the service they provide, and this is infrastructure as a service. I'm sure you are familiar with the OSI model, where you have the network model and at which layer what things are happening. So the cloud also has a similar layered model. Okay, so at the bottom we start with networking, storage, servers, and virtualization. This is basically going more towards the hardware. As we go up the layers, you are going to the operating system, middleware, data, and finally the applications. So the division, if you see here very clearly, the bottom four layers are managed by the service provider. So there are two entities which you always need to keep in mind. One, which is the service provider. It could be like Amazon or Google, and the customer or the consumer, basically you, who is going to use the service. So who manages what layers? So the bottom four layers are managed by the service provider. The top five layers are managed by the consumer. So this kind of a model is called as an infrastructure as a service. Now, when I go to the platform as a service, now the provider manages more number of layers as compared to the previous case. So if you look at the bottom seven layers are now managed by the service provider, and the only top two layers you have to deal with it. This is what is called as platform as a service. So you can have like Google App Engine. This is PaaS, again from Amazon, Elastic Beanstalk, Microsoft Azure. So different companies provide platform as a service, and these are their names. So as it is very obvious that platform as a service will be definitely more costlier than the infrastructure as a service, because now more and more management tasks, control tasks, and monitoring task is done by the service provider. So they will charge you extra money for that. As we go to the next one, which is software as a service, here everything is managed by the service provider. You do not have any role in the management. Now, this can be, of course, this will be definitely more expensive. However, you have to keep in mind that as we give more control to the service provider, we may be at a risk of having how should I say, not controlling your stuff, especially your data and applications. So when you are not sure what is happening in the cloud, you would actually be not very convinced to go for software as a service. So you need to make sure that the software as a service provider, is he reliable, is the company reliable, is the company going to protect my data. Okay, so more from a security point of view. Okay, so SaaS examples like Salesforce, Google Apps, Microsoft 365, these are all software as a service examples. Now, some people actually, have come up with many different types of service models other than these three basic ones, like they say storage as a service, desktop as a service, transportation as a service, accommodation as a service. So various services have come up. So in order to group them all together, we say, okay. Now coming to the next one, which is deployment models. We have public, private, hybrid, and the community cloud. So what is a public cloud? Public cloud is for general public usage. Anybody can use this cloud. Okay. Where does it exist? It exists in the premises of the cloud service provider. Let's say you have Amazon, you have the cloud data center in, I don't know, maybe in Dubai, for example. So that's how the arrangement of the public cloud is. So public cloud will have lots of users, and it will be definitely cheaper. Since you have more customers, you can reduce the price at which you are going to offer your services. But there will be some issues when it comes to the public cloud, because too many users, too much of traffic and data, so network availability may suffer. Okay. And you will have only basic services available to you. Okay. You don't expect too much of service level agreements which will be satisfied by the cloud service provider. So this has its own advantages and disadvantages. That's why people thought of the private cloud. The private cloud is owned by a single organization. Okay, so let's say there is a company. I'll just give you a very basic example, like Sabic here or Aramco. They want to have their own cloud. Then we will say it is a private cloud. The company is the whole and the sole owner of the private cloud. All its employees will be the customers of the private cloud. Of course, this is going to be more expensive. Makes sense, because it is owned by the company, so they have to invest on the setting up of the private cloud. However, this is more secure because nobody else is using the cloud, so you can expect that this is going to be better in terms of security. Community cloud, this is a cloud model, deployment model for those kind of organization who have a common goal. For example, it could be a group of universities, for example. They may go for a community cloud, or they may be a group of some organization. Okay. Maybe some businesses which are running same kind of business. So it's a community cloud. Okay, so they have basically common goals, so their requirements will be same, more or less. So it will be easy for them to set up a community cloud instead of going for a private or a public cloud. Or you could now have a combination of the previous three. You can go for a hybrid cloud, which is a combination here. If you can see here, it is a combination of a public cloud plus a private cloud. So then we will call it as a hybrid cloud. So one organization may have a private cloud, and then it will also use the services of the public cloud for some security based applications which are very sensitive. They will use the private cloud, but those applications which are like kind of not very critical, they would go for a public cloud. So you could have a mix. In fact, multi-cloud is a kind of model people are recently adopting. So they will go for a private and a public cloud, or it could be a community cloud. So multi-cloud model is something which is coming up. As you can see here, the share of the multi-cloud is about 85% of the businesses. They prefer multi-cloud option. Now this takes us to the very important concept of the reference architecture. So when you are building a system, you need to refer to a certain set of guidelines which are applicable in designing, making your system functional. You have provisions for monitoring, you have provisions for updating the system. All these different functions are needed, and they have to be clearly laid down in the form of a set of processes and procedures, and that is part of what is called as a cloud reference architecture. Again, this reference architecture is given by the NIST, which is, as I mentioned in the earlier part of my talk, NIST is the one which is gave this reference architecture. So there are two ways of looking at this architecture model, which is right in front of you. You can go vertically up and down. That is, will give you a list of components which are part of the cloud infrastructure. If you go horizontally from right to left or left to right, that's where you will come across the functions of these components. So let's look from the vertical stack. So let's start from the bottom. Now, if you see, the first thing which you see here, the first layer is basically the physical infrastructure. Physical infrastructure, as I keep repeating, it consists of the compute, storage, and the network. Now, if you go a layer above, we get the virtual infrastructure. The virtual infrastructure. Okay. Now you will go for virtual compute, virtual storage, and the virtual network. On one more layer above, you get the software defined infrastructure. So three types of infrastructure: the physical, virtual, and the software defined. Then the next layer is basically the orchestration layer. Orchestration, if you look at the meaning of the word orchestration, is bringing many things together and managing them in a coordinated way. That's basically orchestration. So here we have different types of infrastructure. We need to bring them together and we need to manage them efficiently as a single cohesive system that would be requiring orchestration layer. On the top of the orchestration layer, now you will provision the services, the cloud services. And finally, on the top of the services, you will have the application layer. So these are the 6 different components in the cloud reference architecture. What are there inside each of these? Of course, we will go into the details as and when we go through our slides, but just as an overview, you should know that in the services layer, you have two important components. One is your self-service portal, and the second one is the service catalog. Okay. Um, Service catalog is basically like when you go to a restaurant, let's say you have a menu which tells us what are the things the restaurant is going to serve us. So service catalog is the menu for the cloud services. Okay. When you go to the applications, you will have two different types of application: traditional versus modern. We'll have more emphasis on the modern applications. Now let's go horizontally across. When we go across, we are looking at the functions of these different components. What are they? Three important functions. You have to manage the services. It's just that you don't provision the services and that's it. You don't worry about that. No, you need to continuously monitor, manage the services. So there are different management tasks which you need to. So this is basically part of operations and management. And second function is basically the security. Keep in mind that the cloud is very much sensitive to this security issue. If you ask any business, would you like to move to the cloud, the first question is they're going to ask, is the security component, if the security functionality, can it be trusted? Okay. So security is a very key concern for those people who want to adopt the cloud. Okay. So we have different frameworks within the security. You have the GRC framework, and you have different, you need to know what are the different threats, and you have to know what are the countermeasures which need to be adopted when we deal with the cloud services. Third one, why the company is going for the cloud? Because it wants business. It wants to digitalize its business and the services. So it definitely needs business continuity aspect. Okay. So business continuity involves three important things: fault tolerance. If there is a fault in your system, let's say there is a network failure. Let's say there is one of the storages is not working. Let's say a group of VMs have suddenly stopped working. These are basically faults in your system. So what are the ways in which I can make my system fault tolerant? In the case of faults, can it still run its business? That's something which is need to be understood. So there are other mechanisms also, like especially when it comes to the data, people are very sensitive. So you need to assure them that you have right backup mechanisms in place. Then we have replication services where the data is backed up at multiple locations. Okay, so this actually is a summary of what is going to come in the slides later on. Okay, so let me get started. Let me get started with this slide, which is if you look at these companies, General Electric, Uber, and Tesla, uh, basically it's a question which needs to be answered. What is common between all these different businesses? Okay, so transport. GE is basically making engines for the aeroplane. Tesla is basically a transportation company. It's a automatic and robot driven or automated cars. Okay, so what is something which is common between all of them? They are based on the digital technologies, and they are adopting the cloud-based infrastructure for developing their services and applications. Keep in mind that these type of businesses, they generate a lot of data which needs to be accessed, gathered, processed, transmitted from one place to another place. For this, they need uh, good mechanisms when it comes to run their business, and cloud is a basically solution to them. Okay, so what is an application? So let's start with the topmost layer, which is the application layer. So this is basic things which you have learned in your basic computer courses. Like application is a set of programs which is developed in order to attain a certain set of tasks, okay, by the user and the businesses. So you have different applications. It could be like, for example, email is an application. Okay, web browsing is an application. Database is an application. So we have different types of applications, and these applications are the end product of any business which is given to the users for their consumption. So we need to make sure that these applications are robust, and they are secure at the same time, and they are efficient in performing their task for which they are designed. Just a very quick how should I say, the progress from different stages or different generations of applications. So if you remember, like in the 50s and the 70s, not remember, you should know that people were basically working with the mainframes. That's if we call the generation one, for example. So it had like many users, millions of users, and you had traditional applications basically running there. And we had like apps in few thousands. Okay, now what happened later on in 80s, the scenario changed. Now the platform was no more mainframe. People started to go for the personal computers. Okay, so these personal computers had a different type of applications which were designed for their use. Okay, so the number of applications increased. Okay, but they were still called as traditional applications. Now, at the same time, the number of users also increase. So when it comes to the PC platform, you had the local area network or the internet, and they follow the client server architecture. Very recently, okay, in the 90s and the 2000s, okay, we are looking for the third generation of the platform where you are looking at mobile computing, mobile devices, and that includes cloud, big data, the social media, mobile applications. So now we have even more number of users, billions of actually users, and now we are looking for modern applications. Later in the slides, we'll see what is the difference between modern applications and traditional applications. Um, So in the traditional application, what one of the main weaknesses was that the different components of the application, they are tightly coupled with each other. That means if one of the component is defective or it fails, the whole application goes down. Okay, and it has a very time consuming process of developing the application. And if you want to make any change in the application, it altogether a different concept. So they are scalable, they have a distributed architecture, can work on the application independent of each other than the traditional application. So a few comparison points which I want to quickly mention here and then pass on. So as I said, modern applications are distributed. They can be done with different types of programming languages. We are not restricted to a single programming language. You could have a mix of like C++, Java, and Python, for example. But in the traditional application, we used only a single programming language. Okay. Modern applications are basically open source also. This is a big advantage of them. Um, they can work with different types of devices. That's another big advantage, because keep in mind that the cloud supports different types of devices. So this is one of the characteristics which need to be supported, and modern applications can do it. Okay. For example, if you want to give some names like Facebook, Uber, Netflix, these are modern applications. However, if you look at email, like Microsoft Outlook, for example, ERP, customer resource management, CRM softwares, these are a little bit more towards a traditional way of looking at things. Okay. So why we need to, or how we can actually modernize our application. So we need to switch from the traditional to the modern. So there are various techniques to do that. You can invest in terms of the architecture. You can adopt different processes which are called lean practices. Um, you can change your infrastructure. You can change your platform. So if you are using platform 2 or 1, then you move to platform number 3, which is the mobile platform, and so on. Just a very quick example of what is called as microservices. So basically, these applications, they support microservices concept, where you don't build a single one big application. You basically partition your application into smaller applications. Like for example, if this is a e-commerce application, so you will have a separate module for accounting, separate module for inventory, and separate module for shipping services. So if it was a traditional application, you would just combine them into a single application. So if one thing fails, everything fails. Here, if the inventory system fails, you don't have to worry, because the accounting and the shipping services will still keep running your business. So that's the microservices concept which needs to be kept in mind. Recently, there has been a very much focus on developing containers. Okay, container is basically a package. It's basically part. We are talking about the software actually. It's a package which is executable. Okay, it is light in weight. Okay, and it is standalone. That means you can move it from one place to another place, and it is portable, and it has all the required ingredients in terms of libraries, binaries, and the configuration files, which can make it execute the application. And it is platform agnostic, meaning you can run it on any type of platform, okay, the hardware. And it is basically, if you look at this diagram over here, we are having the hardware infrastructure, then we have the virtualization layer, which is basically developing the containers for us. So it has a built-in libraries which is executable. So containerization is a very advanced virtualization technique people are now following, and this provides many advantages. One of them is the portability. Okay, I'm sure you have learned this in some kind of course which you have taken, like the waterfall process or the agile process. So agile process is very much preferred way of developing your applications rather than the waterfall process. So there are many advantages in terms of agile. You can be iterative. It focuses on the features, okay, and you can iteratively develop your application, whereas these kind of features are not available in the waterfall. So cloud applications are basically agile. When it comes to the hardware, you would go for those kind of hardware which are based on high speed devices like flash storages, okay, things which are scalable. They can be defined in a software fashion, and they are basically cloud enabled. So the cloud system actually goes for the modern IT infrastructure, okay. um, so what is a service? So let's look at a service. So we have looked at applications. For example, Facebook is an application, WhatsApp is an application. To run these application, we need the support of services from the layer below it. So it is basically a group of IT resources which need to be available for the applications to run. Okay, so as you can see in this diagram, you have a database server, you have an application server. Okay, so these are basically your IT resources. Okay, and this is the concept of the cloud service. So if you remember, I was talking about the service catalog. That's like the menu. Okay. So whenever you go to any cloud service provider, they will present you with this service catalog, which will tell you about all the details of the services which are provided by that service provider. Okay. You can choose your services based on your needs, based on what you want. Okay. You don't pay something for which you don't actually use it. So um, you will have a menu where you can choose. Let's say in this example, he is ordering a virtual machine, for example. So I can choose which operating system I need, how many cores I need. Do I need one core, four cores, or how much storage I need? Okay, how many virtual machines I want to purchase. So all this is part of the ordering of the service through the cloud portal. Okay, cloud portal is basically a web interface through which you can rent the cloud services. I will try to go a little bit superficial because it's taking a lot of time, and still I'm in the services section. So there are various stages in the life cycle of developing a service, which I will kind of skip. This one needs to be like, I can spend some time over here. So let's say you are asking for a service, and this is like purchasing or renting a virtual machine. So if you can see here, we have like, we want 4 CPUs. We can choose the speed of the CPU, how much memory, how much storage, what kind of operating system, which is Windows here. And then it has so many other things like policies, how much is the price, okay, what are the constraints, when you can use the service, how much you need to pay, what are the service level agreements. This is very important. SLA is something which is an agreement between the service provider and the consumer. So both the consumer and the service provider should respect this SLA. If any one of them breaks the SLA, then they have to pay a penalty for that. Okay. For example, if the Amazon says that my service will be available 7 days in the week, and let's say there is one day it is not available, then they are basically breaking the SLA. Okay, so in that case they have to pay the penalty. Maybe they have to charge you less in terms of payment. Okay, so this is all part of the services concept. Orchestration, as I said, orchestration is basically Hello.
Yes, Doctor. Hello.
I'm sorry. I think there was some network problem from my side.
It's okay, Doctor. We
Right. So you want me to continue now?
yes, yes, please. Go ahead.
Yeah. Okay. Okay. So here we have now. Um, so I was actually in the middle of the orchestration. So let's say there is a request for password resetting. For example, somebody has forgot the password, and now um, it has to be reset. So how does the orchestration play the role here? So basically here, the user will make a request. It will go to the self-service portal. And from there, the orchestration will try to coordinate the activities with the IT infrastructure below it. Okay, so this IT infrastructure is either physical, virtual, or the software defined. And then the request is fulfilled and it goes back through the orchestration, then the self-service portal, and back to the user. So now the service gets available to the user. Okay, so in the orchestration, what is happening is basically you are trying to coordinate the activities of different applications and services which are running in the cloud. So orchestration actually goes through what is called as a flow chart of over here. Okay, so if you can, I will not spend much time on this. There are certain decisions which need to be made. For example, if somebody wants to um, get a virtual machine, then uh, you the orchestrator actually has to make a decision whether the resources are available. If they are available, how we should be creating the virtual machine, how we will install the operating system, how we will provide the network services. Okay, all this process is followed, and then finally you basically give the service to the user. So orchestrator follows a workflow, as we can see here. Okay, now coming to the infrastructure, the bottom three layers. So as I said, there are three types of infrastructure: physical, virtual, and the software defined. Physical is the hardware. Okay, so basically you are looking at the compute, storage, and the network. Okay, in the virtual, so you will use a virtualization software actually, which will convert the physical infrastructure to the virtual infrastructure. So everything will become now virtual. The compute is virtual, the storage is virtual, and the network is virtual. Virtual is something which you cannot see or feel. Okay, so um, so what is the advantage of being virtual? Virtual things can be easily moved from one place to another place. Okay, it can be assigned to a certain person and it can be taken away from the person very easily as compared to the physical infrastructure. Many advantages when we talk about virtualization: it improves the resource utilization, it reduces their cost. Okay, and it is more flexible to use. Okay, so how is this happening? How the virtualization actually happens? It is with the help of what is called as a hypervisor. Okay, so when you have the hardware, okay, you have the operating system now. Now, operating system can be optional. You can have an operating system, and you cannot. You can have an hypervisor installed directly on the hardware. So there are two ways of doing it. One is called as the hosted hypervisor and the other is called as a bare metal hypervisor. So hypervisor is basically a software which is going to do the virtualization for you. It will convert the physical infrastructure into the virtual infrastructure. And that's where we get the VM, virtual machine. So this is not a physical machine, it's a virtual machine which has all the functionalities like CPU, memory, and the IO functionality, just like any physical machine. But the only advantage is that virtual machines are portable. You can move a virtual machine from one physical machine to another physical machine. So that gives you the flexibility. So what is behind all this thing is the hypervisor. So we have various examples like VMware, VirtualBox. These are hosted hypervisor. So you can install these hypervisors on your host machine. For example, if you are using Windows machine, okay, running a Windows operating system, you can install VMware, and on top of VMware, you can install any other virtual machine. And this could be running not necessarily Windows, it could be any operating system, like it could be Linux or it could be Mac, okay, or it could be Unix. So you can have the flexibility of having your own operating systems running on the virtual machine. So this is something very important to know when we talk about hypervisors. Now, hypervisors can be installed on the host operating system, or sometimes you don't need an host operating system. These are called as bare metal hypervisors, and very popular ones are the EXSI and the Hyper-V hypervisors. Some another important concept when we talk about storage, which is called the LUN, logical unit number. Basically, you take the physical disks and you make them virtual, and you can do partitioning of the virtual storage pool, and this is called as a LUN. LUN is now a storage which can be assigned to a virtual machine for storing your data. Okay. Just like you can virtualize the compute and the storage, you can also virtualize your network. Okay, so you can have a VLAN or a VXLAN or a vSAN. One important thing is called SAN. SAN is basically the storage area network. It connects a compute resource to the storage resource. That's called a SAN. Okay, but if you connect a compute with another compute, this is called a LAN. So how does the um virtualization help? It helps us in resource pooling. It's very important. So if you look at, we have three machines here. Each one of them have the hypervisor. And now we can, let's say the first machine has 6 GB. Sorry, each machine has 6 GB of memory, and they have 400 megahertz of the processing power. Now, these are three physical machines. Now I can convert them into many virtual machines, which with different processing powers and different memory capacity. So if the capacity is 6 GB, I may not be using all of it. But when I do the virtualization, I can make virtual machines with smaller memory capacity. So I'm using only 2 GB, which I need. So the remaining unused memory can be used by other virtual machine. So here we are basically utilizing the resources, the physical resources in a more efficient way through the virtualization process. The third layer is called the software defined. This is a more and more abstract version of the virtualization layer. So software defined means all your infrastructure is now controlled by the software. You are not dealing with the hardware anymore. Okay, because in between now you have the virtualized layer, and on top of it you have the software defined infrastructure. So you'll find this terminology very popular in the cloud area, software defined infrastructure. Again, now here we will have all the three of them: software defined compute, software defined storage, and software defined network. SDNs. SDNs are very popular nowadays in dealing with network traffic, network routing and switching. So they are very much flexible as compared to the physical network. So I'll skip some of the points. I'm not sure how much time I'm left with. How much is the time which I can speak now?
Yes, doctor, we have 10 minutes more, I guess, or something.
10 minutes more.
About 10
Okay.
minutes, yes.
Okay. No problem. Right. Okay. So this takes us to the, I would definitely like to cover the security because the cloud security is very important. So I'll spend like 5 minutes here and then I will go for the conclusion. So we know that security breaches actually are very having a very negative impact on the business in terms of money. Definitely, you lose a lot of your revenues, and more important than the money, it is the trust of the consumers, right? Who are your customers. So they lose the trust in you because they now know that the services which you are providing are not secure. The data is not secure with them. So they will go away from you. That means you will lose your customers. So that means you lose money, and you also lose the reputation in the market. Okay. So that that means we need to be careful about the security of your data and the applications. So now when it comes to the cloud, things are more difficult in terms of security because you are depending on the cloud service provider to store your data. You're giving the data in their hands, and you basically are trusting them. Okay, so it is a big responsibility on the service provider to respect this trust. Okay, that's the second, the first thing. The second thing is, um, since there is a resource pooling concept in the cloud, that means the resources which are part of the cloud are shared among different users. That means there may be a chance that by mistake, maybe your data may go to the another customer. Okay, because of the resource pooling. So sometimes if you don't, if you're not careful with the way you have used your resources, you may be basically forget to delete some of the data, or you forget to clear the cache maybe. Then the same virtual machine, if it is not reinitialized, it may have your old data which can be passed on to the other customers. So these are the things which actually play a negative role in the cloud security. So we need to be careful about this confidentiality, integrity, and availability of data. There must be clear processes for authentication, authorization, and auditing of your data. Now, if you look at the security in terms of the cloud deployment models, like public cloud versus the private cloud, we know for sure that the private cloud is more secure than the public cloud. So prefer to have your data on the private cloud. You can go for public cloud, but you uh, uh, go with those kind of data and applications which are not very critical to your organization. It's better to follow this kind of strategy, which is called a defense in depth strategy. When it comes to the cloud security, it's a layered approach where each layer is given enough security in terms of data accessibility, that as we go down from policies and procedures to the network, now to the machine, to the application and the data, the security becomes tighter and tighter. So this kind of strategy is definitely needed when we talk about the cloud. Um, what are the different types of threats? These threats are can be also in a normal traditional application, but they are more severe when it comes to the cloud. Okay, so like the data may be breached, data may be lost. Okay, there may be some people who are inside the organization who are basically threat to the data. Okay, so these are called malicious insiders. There may be some weaknesses in your system, like you are not updating your software, you're not having proper updates to the security patches. Okay, um, there could be denial of service threat. Okay, so these are the various kind of threats, and the key point is basically to take corrective actions. Okay, so what are the control mechanisms which need to be in place? You can go for preventive control, that is before the security attack. You can have detective control, which is right after the security attack, and you can have corrective. So once you know what the damage has been done, you can take corrective actions. When we look at the technical security, okay, you can have strong mechanisms for IAM, we call it, identity and access management. You have to make your application hardening. Okay, sandboxing is one of the techniques where you can test any application before you deploy it. Okay, you can have hardenings at different layers. You can have for the operating system, hypervisor, or the virtual machine. Strong encryption is one way. Having firewalls. Okay, you can play with the network. You can segment your network into critical and non-critical. Okay, and you can have strong intruder detection and prevention systems in place. So another very important uh, thing which you need to keep in mind is the mobile device. So mobile devices are now very popular, and they are always used by the employees of the company, and we should make sure that these mobile devices are secure so that the intruder or this attacker does not access your network through this uh, way. Okay. So I wanted to talk about business continuity, but I think we are running out of time. So I will just summarize this in two words or two or three sentences. Business continuity is basically in case of failures in your system, is your system good enough to keep running in spite of these failures so that you don't lose your business? And there are various mechanisms which you can adopt here, and one of them is finding fault tolerance techniques. So if you have, let's say, storage and you want to make sure that you don't lose your data, so what you can do, you can take your data and make a copy of the data in another storage. This is called backup. Or you can have multiple copies. This is called replication. So there are various approaches which can be adopted. So in case one of the thing fails, you can always go back to a copy of it. Okay, and this could be in terms of storage, network, compute, or it could be in terms of the site. For example, you can replicate the whole data center. Let's say one data center is in the Middle East, the other data center could be in the Africa, for example. So if there is, let's say, an earthquake in Africa, like for example, your data center is lost, but you can always get your services from the data center in the Middle East. So this is what is called as site redundancy. So there are various approaches which we don't have time to go on right now because we need to kind of um, finish this talk. I will just take a couple of minutes um, to talk a little bit about what are the um, research which we are doing here in PMU in terms of the cloud. Okay, so we have a group here which is working on the cloud computing research, and I would just like to present some work. Before we go there, you need to know uh, some key terminologies when it comes to cloud, which is edge computing and the fog computing, which have come up very recently. Instead of sending your data for processing and storage in the cloud, what you can do is you can process the data at the edge itself. Edge means this could be your home or this could be your office where the data is actually originating. So if you process the data where the data is, it will save time for sending the data to the cloud and getting the results back. So you save on the latency part. So the edge computing is becoming very popular. One disadvantage of the edge computing is that you don't have enough computing resources. Like for example, if it is an IoT device, it has very limited CPU and memory. So you can process only limited amount of data. But in the cloud, you have a big resource in terms of different capabilities which you can use in the cloud. So again, you need to decide which one you want to go for. You want to go for speed, or you want to save on the latency for sending and receiving your data. So each cloud, edge, and the fog, they have their own advantages and disadvantages, and based on the applications, people prefer to use cloud or the edge. Okay, so uh, just 2 or 3 minutes and then I finish. So we are actually doing research in terms of cloud services, how we can provide better quality of service by doing admission control using machine learning here. And in the second one, we are comparing the centralized versus distributed approaches for admission control. Again, we are using some machine learning techniques in order to gather and process the data. In the third one, we are actually working on the uh, virtual machine migration, how we can do uh, virtual machine migration and how we evaluate the performance of it. Okay. And we are also working on the smart city emergency services. And smart city is basically a collection of IoT based devices. Okay, so various sensors, we collect data from them and then we try to model the smart city services. In summary, I just want to tell that we looked into some of the details of the cloud computing enablers, why the cloud computing has become, and we found the answer is digital transformation. We spend a lot of time on the architecture and the components and the functions of the cloud reference architecture. Um, we spend some time on the security of cloud, then some related technologies like edge and cloud computing and fog computing. However, uh, before I finish, I just want to tell you that cloud computing is not all good. Okay, there are certain challenges which are there in any technology. If you want to look at it, there will be definitely some challenges. So, cloud computing is basically not the answer for every solution, every problem. Okay, it does not have solution for all the problems related to computing. Okay, so if you look at this last slide here, uh, one of the students is saying to the teacher, my dad says the cloud is the answer to everything. So in the test, he was asked a question and he gave the answer uh, for all the answers as cloud. So definitely this is not the correct answer. So with this, I just want to conclude my presentation. Would like to thank my university for providing this material for presenting, and I would like to acknowledge their support in the research work which we are doing here at PMU. And thank you for listening.